Hi, good afternoon, everybody, or good morning, good evening, wherever you are. This is Giles at ShapeBlue. Welcome to this ShapeBlue webinar, first look at CloudStack 4.14. Presenting today is myself and Andrea Panic, who's one of our cloud architects and was also the release manager for CloudStack 4.14. Are you online, Andrea?
Right. Hi, everybody. Hope you're having a good time.
Cool. So I'll do most of the talking. Andrew's going to do most of the clever stuff. Before we get into the agenda, I just want to say, hope everybody is well and keeping well during these weird times. And the other thing just to say is that we're all at home like you, so we're doing these webinars under lockdown conditions. We've all got our families around us, so please don't be so surprised if you get the occasional interruption from one of us. This is a ShapeBlue webinar. We're talking about the recent release of Apache Cloudstack 4.14. In terms of what we're going to cover, we're going to have just a quick look about the timelines on the release, its EOL dates, etc. And then we're just going to dive into features. Now, 4.14's got 200 new features and improvements, so we're not going to get through them all. We've cherry picked what we think is the most interesting, and that's the list there you can see in front of you. The first few of those we're going to talk through and then do a very quick demo of each of those, and then the latter half we're just going to talk through. As I say, it's a first look. The idea is just to give you an idea of the use case of each of these features, what they're designed for, how they hang together, where to go and find them, and that's it. We're not going to go into a huge amount of detail. Time permitting, we'll aim for sort of 10-15 minutes of Q&A at the end. For questions, please use the GoToWebinar question button. You should have it on your client there. That's what it looks like on a Windows or a Mac desktop. I think on tablets and things it looks a little bit different. When we get to the end, we'll then work through those questions and try and get through as many as possible. If we don't get through them all, we'll follow up with an email, etc. I know I had a quick look at the attendee list. We've got 102 people on this webinar today, which is fantastic. A lot of you guys we know, you're people we work with in the community or your customers, etc. Please feel free to contact us directly afterwards if you want to. And those of you who are come along to find out about CloudStack for the first time, please feel free also to drop Andrea or me a line. So questions on the GoToWebinar question feature, please. Okay, so CloudStack 4.14, official name, semantic name 4.14.0, was released last week. It is the winter LTS long-term support release. CloudStack has 2 releases a year, summer LTS, or 2 LTS releases a year, summer and winter LTS. And I guess some of you are there probably looking out the window going, oh, it's not winter anymore. You are correct. It's late. This release is late. It's been a very, very big release. It did delay because of the scale of it, and then throw in the fact that everybody's working lives changed just as we were getting it ready to go out of the door. A lot of people not spending as much time in open source communities has meant we've got to the end of May. But the next release, the summer LTS release, should be following actually quite soon, sort of end of August sort of time frame. The end of life from a community perspective, CloudStack community perspective for 4.14 will be January 22, and the previous LTS version, which is 4.13, is about a year from today. As I said, 200 new features and fixes roughly. There's a link for the release notes. I encourage you just to go and have a flick through for the full information there. As I say, we've just cherry picked what we really like in this release to talk through today. So let's get started. First, CloudStack 4.14 introduces a backup and recovery framework. CloudStack is the 2 use cases for CloudStack are basically private cloud and public cloud. The latter one, people who are offering cloud services to their customers, is probably the dominant use case with CloudStack. And until this point, if those operators, those service providers, wanted to offer any form of backup to their customers for the virtualized infrastructure, all we had was snapshots. I mean, snapshots do their job. They're they're snapshots, but they're not a backup. If you use VM snapshots in CloudStack, they don't even move off primary storage. You can't even, they're still on the same disk. Using volume snapshots, we've then got problems with, consistency. They're not application aware. They were slow because we're moving data between primary and secondary storage, and then a really convoluted restoration process of creating a template based on the snapshot, then creating a VM based on that. So this has been a long time coming. We've got now the CloudStack backup and recovery framework. And the thing to make clear about this is it does not do backups, right? This is a framework to allow CloudStack to be integrated with third-party backup providers. CloudStack's ethos, in a way, is keeping a tight scope around what we do as a project, and there really is no point reinventing the wheel when there's 101 sensible backup solutions out there, which are often already in place in those environments. So we've got a framework. That framework is pluggable, and what it allows us to do is expose a common set of backup operations: create backup, create schedule, restore, etc., a common subset of those across any backup provider into CloudStack, into its API, and into its user interface. The use case that drove this was based around the organization who drove it, that was based around Veeam. So there is a provider, effectively a driver for Veeam, and there's a dummy provider, anybody who's developing. But the idea is anybody is free to go and create new providers for any backup technology. Those providers can be set per zone, so we can have different backup technology going on in different zones in our CloudStack environment. Gives support for both policy-based backups and user-based backups. So the idea of policy-based backup is, as a service provider, you want to just say, look, we've got this backup offering, we call it Gold, and Gold is a daily backup with 2 hourly incrementals or a restore point objective of X. And then how we actually back that up is we will worry about that as a service provider. The end user, the end consumer, doesn't worry about that. Now, the advantage of that technique for service providers is that then lets them get smart in terms of, when those backups actually happen, making sure that we don't get every user in our environment all backing up at 12 midnight or something like that. Or the other option is we can create user-driven backups, and that's where the end user then has control to create a schedule, do ad hoc backups, etc., etc. Obviously, the framework provides restoration even after the original VM is destroyed in CloudStack, which is interesting, and that's possible because we're using a third-party backup provider. We can restore individual volumes, and most importantly, from a business perspective, this is all integrated into the CloudStack usage service. So if anybody's listening to this who's thinking, yeah, we want to offer backups, enterprise-grade backups through CloudStack to our customers, you don't have to do any sort of calculations or anything. CloudStack's going to record all of that usage in terms of number of backups, amount protected, etc., and you can then just push that through into your billing systems or business systems. In terms of setting this thing up, there's some global settings and then some per zone settings, and these are basically about enabling the framework, pointing it to the correct provider, configuring CloudStack to be able to connect to that provider. We then have a concept called backup service offerings. I'm going to demo all of this a little bit later, which that creates the mapping between the backup provider, i.e. Veeam in this case, and what your users in your CloudStack environment see. And then ultimately users then have control of that life cycle in terms of then backing up or restoring, etc. And all of this functionality is in the UI. It's all also obviously in the API. So if you want to do any batch backup operations, they can all be done via the CloudStack API. So that's the backup and recovery service. the next feature to have a look at is we have a new user interface for Apache Cloudstack. Apologies for those of you, we did a webinar, ShapeBlue webinar a few weeks ago specifically about this, but we've got many more people on this webinar today, so I'm going to just go back over some of that stuff. This is a project that's been in development for about a year. It became a sub-project, a special interest group in the CloudStack community. Its code name was Project Primate. And what is shipping with CloudStack 4.14 is the technical preview of Project Primate, of the new user interface. It is not recommended to use in production environments yet. The existing user interface is still the supported user interface for production environments. And actually for my demos and everything today, I'm going to mainly use the existing user interface. I'll explain why in a second. In terms of that new UI, it's a clean, modern, updated user interface. I think much more intuitive to use than the existing user interface. The main driver for doing this was the existing user interface was getting very cumbersome in terms of building features and extending it and configuring it, etc. So sooner or later, some investment had to be made in terms of time to actually create something that was easier for people to start to develop in. As I say, it's been about a year in development. What is releasing at Tech Preview basically just has feature parity with the old UI. So there's no new features to look at, apart from it's a different experience, but all we've got is a new version of that user interface with the same functionality in it. There are some nice advantages. First of all, Primate is a separate code base to the management server. It can be deployed on any server, on any web server, and pointed to a CloudStack management server. So obviously that gives us flexibility in terms of deployment, also in terms of updating and managing of that UI. We've got a lot more options now. It also has API auto discovery. So as new APIs, new features are added to Apache Cloudstack, those features are going to magically automatically appear in this user interface. Obviously, what that's doing is reducing the ongoing maintenance overhead of the user interface. It's got proper role-based rendering. The old user interface used to rely on the developers to hard code the hiding and showing of buttons if somebody shouldn't be seeing it. And that's why the old UI often had buttons you could click and then it just said you haven't got permission to do it. That doesn't happen anymore because the UI is rendered based on my permissions. It does things like supports browser history, so you can use the back button, use URLs. It works on all browsers. It works on tablets, on phones, etc., etc. It's based on Vue.js and Ant Design. One of the big drivers for choosing particularly Vue.js was how quickly it is for software engineers to get on board and learn Vue.js. So what we've basically got here is a new UI which is going to be much easier for people to extend going forward. So the official line on this user interface is, as I say, what's being released, or what was released last week, is a technical preview. The idea of that is to give those of you running CloudStack environments time to get familiarity, to test with your integrations, with your business processing that's there, and also to think about, if you've got user documentation and that sort of thing, to get that updated, because you're going to have to move to this new UI sooner or later. But as of last week, when Tech Preview was released, no new features are being accepted into the existing UI. At the next release, which is going to be, say, roughly end of August, that sort of time frame, that will ship with the GA version of the new UI and also the old UI again. But the point being is you could migrate to that new UI at that point. And then in the following version, which will be around the turn of the year, the old UI will be deprecated. So if there's one takeaway from this today, those of you running CloudStack environments, you need to think about this new user interface. There's a few bits missing from the Tech Preview. There's no user documentation yet. There is install information, documentation and all of that, but the user documentation hasn't been updated, the translations aren't there yet, and there's a few features which haven't quite made the cut yet. Interestingly, for today's webinar, a few of the 4.14 features we're going to look at today aren't yet in the new user interface because they were still being worked on after the code freeze for the new user interface. But all of this will be remedied by the time we get to general availability. So for purpose of demos today, we're going to use the old UI mainly. Okay, the next headline feature in 4.14 is VM ingestion. So it's a question often gets asked. People say, okay, we've got CloudStack, we like what we see, we want to deploy a CloudStack environment, but we've got a very big virtualized infrastructure already, and we want to just hoover that up and bring it into CloudStack. And that conversation seems to be happening more and more around people who are running VMware-based environments based on vSphere. And I'm guessing a lot of that is around people thinking about long-term migrating hypervisors, thinking about having flexibility about what hypervisors they use. But the first thing they want to do is to take that existing virtualized infrastructure and bring that under the control of CloudStack. That's exactly what this new VM ingestion functionality does. This works only with VMware, so this can't be used at the moment with KVM or any other hypervisor. The use case is around taking a vSphere environment and bringing that into Apache Cloudstack. And what the functionality does, it will import a vSphere data center into CloudStack. When I say import, really think of this as putting it under CloudStack's control, because what it doesn't do, which is actually its cleverest feature, is actually start moving the VM around from place to place and having to start and stop it and what have you. What this does is it takes an existing VM in vSphere and says, right, I'm now going to retrospectively tell CloudStack that it is managing that VM and tell vSphere that that's happening. If you think of that compared to the previous process, which would be, exporting template OVAs, importing as a template into CloudStack, doing all the networks, doing the service offerings, then creating a VM based on that template, then it is a very long-winded process. This is now a single API command to bring a VM in. And that's an important point, actually. This is API only, it's not in the UI, because by definition, people will want to batch this. They'll want to script this to do multiple VMs and whole data centers. So what we've got is two new API commands. First of all, if it's not already, you have to make sure that you have a CloudStack zone pointing to the vSphere data center. We have two new API commands: list unmanaged API instances, which will ask vCenter what VMs it has that CloudStack doesn't yet know about. And most of the work is then done in the second API command, which is import unmanaged API instance. Andrea's gonna demo this shortly, but basically we give it a bunch of parameters, tell it the name of the VM, etc., etc. We can do things like specify what network we want it to go on, service offering we want it to map to, etc., etc. Or we can leave a lot of those things out, and the API, the CloudStack, will actually make those decisions for us. So, for example, with networks, it's got a very clever thing. If you don't specify the network ID, it will go and find the appropriate network based on the VLAN ID that it's got from VMware. It's some very, very clever functionality. There's also a script that's been created as part of it, which you can just use for going and discovering networks independently. So that's a VM ingestion, and so that's API only. Okay, next new feature is the CloudStack Kubernetes service. I guess everybody on this webinar has heard of Kubernetes. What's this all about? Well, this is about giving CloudStack operators the ability to offer a container as a service offering, or you could even think of it as a Kubernetes as a service offering, but from inside of Apache Cloudstack. And the reason to do that is that a lot of organizations, again, particularly the public cloud providers, have got business process, they've got portals, they've got all these things and environments that are pointing to CloudStack. So this is a very, very easy way, requiring nothing more, to be frank, than an upgrade of CloudStack to allow your users, your customers, to start consuming containers via Kubernetes. Key point there is no disruption to user experience or business process. So all of this is based on the same model that Google used for their container service, which is basically you pay for, you consume underlying virtual machines. That's what you actually get billed for. And what you're doing is creating a container environment orchestrated by Kubernetes on top or inside of that virtualized environment. What it basically is some functionality, both UI and API. It creates, we get a concept called the Kubernetes cluster construct in CloudStack. And that functionality, when we create a cluster, we'll go and create all of the required supporting VMs of the correct type. It will choose a specific template based on a nice lightweight operating system. CoreOS is what's used by default. It will install and configure Kubernetes. It will configure those hosts into a Kubernetes cluster with the appropriate master and the appropriate worker nodes. It creates all of the networking pieces, the firewall, load balancing, port forwarding to allow people to get in and administer that using whatever tools they want. It creates the secure access endpoints, but what it doesn't do is actually orchestrate the containers itself. You do that through Kubecontrol or the Kubernetes dashboard or what have you, which is, yeah, we don't want to reinvent the wheel here. Now, some of you know CloudStack quite well will realize that there was something similar to this 2 or 3 years ago we talked about, which was called the CloudStack Container Service. And in terms of functionality, actually these two things are very similar. The container service was designed to be a generic plugin for CloudStack that would allow CloudStack to orchestrate any type of container orchestrator, so Kubernetes, eventually Docker Swarm, whatever. The problem with going that generic route is we were only ever going to have a subset of functionality across all of those different container orchestration platforms. So a decision was made going back a year or so to say, look, realistically, most people want Kubernetes, so let's double down. Let's drop the generic approach and just go the route and call it the CloudStack Kubernetes service. So that container service, although provided the, if you like, the prototype for this, but this is new functionality. How it orchestrates things is completely different. It's all based on native Kubernetes stuff. And what that's doing is then opening up for the future the ability to start to bring in a lot of very Kubernetes specific functionality into this plugin. For example, now we can scale clusters easily. We support multi-master. That was always difficult because we only had a common subset before. So that's the Kubernetes service. So now is time for us to do a few demos. So what we're going to do is just run through and have a very quick look at those items I've just been talking about there. I'm going to start and do a few of them. Andrea's going to pick up at the end. So give me a second. And I will also say, obviously, I'm working at home, so I'm at the mercy of the demo gods. Good. It appears I have a network. Okay, so first thing we're going to look at is backup and recovery. So I've got here an instance of CloudStack 4.14 with a few sample VMs in it. I've already got the backup and recovery framework installed, configured, and a Veeam server running in the background, which is actually doing the heavy lifting of the backups. Just going to show you what that looks like from a user perspective to start with. So I'm going to go, well, I'm going to log on. I'm going to log in as an administrator simply because otherwise I would be jumping between an admin and a user all the time. So I'll just show you everything. Oops. This is not going well. Perhaps log. Okay, I'm just going to find an instance that's already being backed up by the backup and recovery framework. I've got this instance called BR1. First thing you'll notice, because we've got the framework enabled, I've now got this view backups as well as view snapshots. So I can use that to just go in and see. This has just been running today since I set it up. So there's all the backups I've got, what type of backup they are, and I've got instant functionality there to pick any of those backups and go and restore from that point, or restore and attach the backup volume itself. It's that simple. I've also got buttons in here, a couple of things I can do. I can start a backup manually. Here I can go and change my backup schedule and choose, you know, how I'm doing it, hourly, daily, weekly, etc. This is a user-controlled backup. So this has been configured by the administrator to allow the user, because otherwise, if I just set them up as policy-driven, I can't do any of this because the system just does the backups. Okay, and just to show you, before I could do any of that, if to actually get the machine backed up, I've just got another instance here which hasn't got any backup protection at the moment. What I'd need to do is actually add the machine to a backup policy of some description, or sorry, a backup offering of some description. I choose the backup offering, which has been configured by the operator, by the service provider. I've got a couple of examples here. So bronze and gold, which are policy based. So I haven't got any control over when those backups are done, how often they're done, but that would be down to the service provider to say, this is what gold means, this is what silver means, or a self schedule. So for example, I could say, right, I want this machine to be protected by gold backup. That's it. Okay. So on the admin side of backup and recovery, this is a per zone thing. So I go in and find the relevant zone. This zone's called London in this case. First of all, just have a quick look at some settings, which are all will back up something, whether the frameworks enable, what provider it is, Veeam in this case, and then the rest of it is basically how to connect to the Veeam server, credentials, etc. So that creates the relationship between the zone and the provider, which in this case is the Veeam provider, and the Veeam provider is then going to communicate with the Veeam API for all of the operations. Once I've done that as an administrator, I need to go and create my backup service offerings, and that's in with the other service offerings. We've got compute, network, etc., but we've now also got backup offerings, and there you can see the list that I chose as a user in terms of what sort of backup I wanted. Now, important thing to realize here, I can't create a new one here. I have to go and configure something in my backup provider. I'm not going to do that now. I'll have to jump to a different server, but I'd have to go and configure something here in Veeam. Veeam calls these jobs. Different backup providers call these different things. That is then mapped by the provider, and then I import that and create a service offering based on it. So I'm just going to sort of go through the motions of that, creating a silver one. Okay, choose what zone I want to push that into. If I leave it blank, it's going to go into all zones. Okay, and then this is the job ID coming in from Veeam, or it could be, you know, a template ID coming in from another backup provider. That's just how the provider has mapped them. Okay, and now very importantly here, this checkbox, allow user-driven backups. If that's checked, the user is allowed to manually start a backup and create their own backup schedule. If that's unchecked, they can't do either of those things. So it is purely a policy-based backup. Okay, that is backup and recovery. Next, I'm going to move on to CloudStack container service, and you should notice, hopefully here we have, sorry, I've used the old terminology, CloudStack Kubernetes service, the Kubernetes service here. And what I have listed here is, in fact, I've got two here. These are Kubernetes clusters. Okay, so this is what the Kubernetes service creates. It creates these clusters for us. Each cluster is a number of virtual machines configured as a Kubernetes master or multiple masters and multiple worker nodes. It's also got, obviously, Kubernetes configured and turned into a cluster, and it's got all of the appropriate networking set to allow access through to that cluster. Okay, so if I just quickly have a look at one of these clusters, there's not much to see here actually. I can see the underlying instances, the underlying virtual machines that this is running on. Notice we've got one master here and then 3 worker nodes. I can see the firewall configurations. It's a standard CloudStack firewall, load balancing, port forwarding, which has all been set up by the Kubernetes service in advance as I created the cluster. So go back in. I've got instructions here how to actually access the cluster using kube control or whatever tooling I want to use. And then probably most importantly, in order to be able to do that, I just click this button here and it will, on the wrong screen, unfortunately, I have to drag that across, give me the configuration file. There we are. That I would need to pump into kube control or into a local proxy or whatever, however I'm going to actually access that cluster. So to create a new Kubernetes cluster is really, really simple. Here, have a webinar cluster. Okay, choose what zone I want to deploy it in. Choose what Kubernetes version I want, and I'm going to come back to this as an admin in a second. I can choose any Kubernetes version that is installed and configured in my environment. And notice as well, if I choose different Kubernetes versions, I get different options depending on what that version of Kubernetes supports. I choose the service offering that I'm going to use for the underlying VMs. And again, there's quite a lot of integration gone on here because depending on the Kubernetes version, I get offered a different set of service offerings depending on the minimum requirements of Kubernetes. I can specify root disk, etc. network. If I leave that blank, the Kubernetes service will go and create a new network for me. Choose the number of worker nodes I want. Let's just go with 2. I can also put the SSH key pair in for the underlying VMs. We'll have to come back to this. This takes, realistically, with a couple of nodes, that will take 10 minutes to actually go and create before the cluster is fully online. But what you should actually see quite quickly is if I go into my instances. Nope, not yet. I was too quick there. We'll start to see the instances being created next, etc. behind the scenes. One last thing on the Kubernetes service from an administrator viewpoint, the admin we need to do is actually in here as well. You have this drop-down list. I wouldn't have 2 things in the list if I was just a user. We have the Kubernetes versions. And this is like a service offering for Kubernetes. And in fact, I was thinking earlier, well, maybe we should have put this in the service offerings area of CloudStack, but it's not. It's in here. So this is an admin-only thing, and these are what's driving the different versions of Kubernetes that I can actually deploy. To add a new version, I go in, put the semantic version in, give it a name that people are going to see. What zone do I want to put it in? The URL is a URL to an ISO, which contains the underlying image, operating system image, and the Kubernetes binaries for that version. Now, if you look at the CloudStack download area or the ShapeBlue mirror of that, there's ISOs pre-built for I think pretty much every current version of Kubernetes, and that will be maintained. But as a service provider, you might want to build your own underlying ISOs. Also important in here, this is where we specify the minimum number of cores and memory that is required to run that version of Kubernetes, and that will then be used to filter the service offerings that users can then choose. That is the Kubernetes service, and the last thing I'm just going to do a quick demo of is the new user interface, and for various reasons I'm going to do that in a different browser. So here we are, the lovely new shiny interface for Apache Cloudstack, technical preview. Notice we've got all the same single sign-on stuff, the SAML authentication and what have you. Again, I'm going to just go in quickly as an admin. As I log in, I just want you to notice at the top, towards the top of the page, there, discovering features and discovered all available features. That's the auto API discovery I was talking about. That's the new user interface going off to the API and saying, look, based on this role, in this case it's admin, or it could be whatever my username is, what is this person allowed to see? And have you got anything new that I should be displaying to him? Demoing this for those of you, those of you who know CloudStack, we don't need to do a massive demo here because the features, the concepts are all exactly the same. It's all the same concepts. It's just done in a bit of a nicer looking way. We've got obviously the ability to do things like show and hide the navigation. The dashboard looks pretty much the same. If we look at, for example, instances. Okay, just one thing I want to show you. We've got pagination, the sorting's much faster and much better. We've got much faster searching and a lot more consistency than the old UI. If I'm searching instances, it's exactly the same if I go and look at networks. It's exactly the same if I go and look at Kubernetes clusters or what have you. So it's a much more consistent, intuitive UI. The other thing that I've found really useful since using Primate is we can click through a lot more now. So the old UI used to be really frustrating. You were in a virtual machine trying to get some details about it, and then you had to go and click somewhere completely different to look at the, I don't know, the virtual router and the network it was mapped to, etc. But now we can, we can just click through from place to place. So I'm looking at that instance there, and I could drill through from that instance, for example, and go and look at, what zone is that instance in and bring up the details of that zone. When I'm on the zone, I don't know, I might go and look at the physical networks as part of that zone, and I can just click around and find things much quicker than I could in the old UI. Another couple of nice time savers with it is it's URL driven. So the old UI, you could never see where you were. You could never navigate with URLs. So if, for example, I was got a problem with a host here and I wanted to get my colleague to take a look at that host, I could just, email him that URL, just do it in a different tab, bang, he can go or she can go and find that host directly. Back button works, etc., etc. Couple of other things worth looking at, just to mention, because the translation of Primate isn't complete yet, but we've got dynamically loaded translation that's Japanese, I think, and you can actually use that to see the bits that aren't yet translated. Let me just go back to English, or I won't know what I'm doing. And then obviously it's a responsive design, so as I rescale it, things are going to change. If I put it on a phone or a tablet, it's going to change. It's a completely different thing to the old UI, which is sort of handcrafted. That is pretty much everything I wanted to demo. I'm just going to hand over to Andrea. Andrea is just going to talk us quickly through VM ingestion. Is that correct, Andrea?
Correct, yes. Thanks, Charles. All right. You should hopefully see my screen with VMware, some console, and here's the CloudStack as well. So here's an example VM un-VM like unmanaged VM. So this is the VM that exists only in vSphere and doesn't yet exist in CloudStack, and we can actually search for it, so you can actually kind of see the proof that it's not there. And actually, I here already have the exact command, the bare minimum, which is needed in order to be able to import this VM. So effectively, we are using the import unmanaged instance API. We are passing the cluster ID. This is the ID from the CloudStack database, the ID of the vSphere cluster as visible in CloudStack database. We are also passing the name of the VM as it exists in the vSphere, and the bare minimum that we do need to specify is the service offering ID, which is effectively the compute offering ID that will be used for this VM. If you read the documentation, you will see awful a lot of variations and options to import things, but this is the bare minimum. What will happen now, let me just first show you, is that this VM, if we go to its networks, you can see it's connected to a network which with specific VLAN ID 1497. But yeah, for the moment, let's just remember that fact. And I'm going to hit enter on this API call right now. And you will get a very long output, which is the same as the output of the create virtual machine API call. And now this VM has been imported. If we go back to the CloudStack and refresh our search button, you will actually see this VM which I have just imported. You will see a specific network to which it was auto-mapped, because this specific network, which was pre-created in CloudStack, already had a VLAN, same VLAN 1497. So for example, you can stop the VM. Let's run to the vSphere. You will see here a task to power off. As you can see, this one doesn't have VMware tool, so it does the power off of the VM. Once we start the VM first time ever from CloudStack, CloudStack will reconfigure the VM to move its network to a new port group, which is the cloud something something as usual. And that's pretty much it. You can control the VM, do whatever you need with it, and so on. And that's briefly VM ingestion. Again, this is the bare minimum where the network mappings are done automatically based on the VLAN ID. But if you have a more complicated output, you will be able to control this explicitly via different parameters and its values and so on. So yeah, that's all from my side. I'm going to hand over to Giles again.
Thank you, Andrea. Guys, I hope these demos, we're not going too fast through these. We had a lot of discussion about whether we should do a bit more detail and what have you. And we thought with the first look, we just want to give you a taste of this functionality. But happy to get any feedback afterwards. Andrea, can you see my screen okay?
Yeah, all good.
Yeah. Great, thank you. So next new feature, KVM rolling maintenance. We're not going to demo any of these features from now on. We're just going to quickly talk about them, because basically a lot of them don't make sense to really demo them. There's not that much to see. Okay, this is for maintenance procedures on the hypervisor hosts, and as its name suggests, it's only for KVM at the moment. It's a framework for allowing patching, upgrading, anything you want, any bulk actions you want to do on your hypervisor host. It's performed on a rolling host by host basis. And if you think about it, I mean, there's lots of different ways of doing maintenance on your hypervisors. I know, a dozen different ways that people who are listening to this use in their environments, using config management tools, handcrafted scripts or what have you. But the big problem with the CloudStack world is that what we really want to do is do this gracefully and transactionally, right? So we want to go out, do some checks. If it's safe to do it, we want to put the host into maintenance mode. We want to move VMs away and migrate them away. We want to do our updates, bring it out of maintenance mode, check it's all work correctly, and report any exceptions and errors. And that's what this functionality does. It sends commands via the KVM agent, so there's no SSH involved. That's for security reasons. Obviously, it's an admin-only feature, and as its name suggests, is only KVM at this stage. We've got an agent properties file that defines a hooks directory, and that hooks directory has 4 hard-coded script entry points. Now, what goes in those scripts is completely up to you. That's effectively your payload for the maintenance. We've got a timeout setting. We can pass in parameters to those scripts using a payload parameter on the API or in the UI. And we can also control how it reacts to failures with a forced parameter, which will, in short, if forced isn't switched on, it hits errors, it's going to stop. if forced is switched on, it will stop on one host and move to the next host. That's it in summary. The overall process, first of all, we have the pre-flight check scripts. They run across all hosts before anything else is done. So these are your precursor checks. It's, you know, can I get to the repos I need? Can I get the data I need? You know, am I overall in a condition to do this maintenance? And if pre-flights fail, nothing happens, right? So that's checking. I want all of my hosts to be in this state before I'm going to try and do this maintenance. As long as it has no errors, it will then move on host by host, and it will execute a pre-maintenance script. And in that, you might use that to start to download some things, start some processes that you need to do in advance of the maintenance. It will then put the host into maintenance mode. Obviously, that will then make the VMs on that host start to migrate away. Once that happens, the maintenance script gets executed, which actually is doing the work you want to do. The host gets taken out of maintenance mode, and then we've even got a post-maintenance script which can run for tidying up. Just to give an example, probably the most common example with KVM, you want to update the QEMU version. So just an example of what you would want to do at each stage. So the pre-flights check, checking the connectivity to the repo to make sure that they can all get to that before we start, that sort of thing. You obviously do other things. Once that's passed, pre-maintenance per host, we might do a test to check if that host is already at the target version and return an error for that host if that is the case. What happens after that error then depends on whether you're forcing it or not. And again, at pre-maintenance, you might want to download the packages, the binaries locally to get them into some sort of temp folder or something. The host then gets put into maintenance mode. CloudStack will migrate the VMs away. Then the maintenance script runs. In this case, we'd actually install the new version. The host gets taken out of maintenance mode, and then a post-maintenance script runs, which in this case, we would probably clear down those temporary packages that we've downloaded and maybe do one final check. The framework has an error reporting process. So basically, when the scripts return 0, it's good. If they return anything else, that then gets sucked back into the rolling maintenance functionality, and it can then decide what to do when those errors come back. Just flick back quickly. More than likely, you'll do this on the API, but you can. There's the button there, and this can be executed against a host, a cluster, multiple hosts, a whole zone, a whole pod, a whole cluster, any scope you want. Okay, a really nice piece of functionality. We all know virtual routers are one of the pain points with CloudStack, and making sure those virtual routers are managed and are operating correctly. So 4.14 has detailed health checks running on for virtual routers. And what it's doing is monitoring the status of every virtual router. It has 2 different types of tests, basic and advanced, and they run on 2 different time-lapse schedules. And the basic concept there is the basic tests are very fast, easy things to run, you know, memory usage, CPU usage, etc. The advanced checks may be things you want to do only once an hour or even less frequency, probably because they're expensive in terms of resource on the virtual router itself. Health checks also has a self-healing option, so you can specify any number of tests that if those specific tests fail, you're going to self-heal, which in this case is just recreating and reconfiguring the virtual router. You get to it by going into the virtual routers list in infrastructure. You can then see there we've got a list of what's in a basically a green state or what's in a red state. Out of the box, the basic health checks, connectivity, free disk space, CPU, etc., they're actually all listed there on the right. And if you go into the virtual router in the UI, you can see which one of those specifically has failed. On the advanced side, most of these tests are around making sure that the virtual router's configuration hasn't got out of sync with the management server's configuration. They're a little bit more expensive to run. They involve database queries and things, so they're run as advanced tests on a different schedule. To set this up, there's a load of global settings, router.healthcheck. The scripts which actually run the tests live in the health checks directory in each virtual router. And there's two different types of tests, as well as the basic and advanced for easy tests and more expensive tests. They either return a Boolean or they return a number. Number being memory usage percentage, CPU percentage, etc. This is extensible, but at the moment only for Boolean tests. So if you wanted to create a new test on a virtual router, you would create the script to actually execute that test and return the results. You would add it into your virtual router or put it into the underlying template if you wanted to go out to in the future. And then you would just go and configure it in global settings to point the health check service at that new test. It's as simple as that. API command there, get router health checks, which will get the current health check status of any virtual router or all virtual routers, and you can even force it to go and execute the tests again. They're stored in an underlying table called router health check if you want to go straight into the database. Now, chances are most people will probably want to push that data out into your monitoring platform, and you could do that by calling that API, getting to that table, or they are actually any failures go out into CloudStack alerts as well, so you could also use that as an entry point to then get it into your workflow, etc. Okay, unrelated to that, we can now pass additional arbitrary configuration data on creation of a virtual machine. So anything the hypervisor can accept as a parameter, we can now pass effectively as a string through the CloudStack API. And I say through the API because at the moment this is API only functionality around some very specific use cases. I hope certainly to see this in the UI at some point, hopefully in the next release. So there's now an extra config parameter on the deploy virtual machine API, supports the three big hypervisors. We've got control at an admin level over what can be passed to that. So we've got a whitelist per hypervisor of what commands we can actually send into that. And we have to pass URL encoded strings. So just a couple of examples there. If I wanted to enable huge pages on a KVM VM, that's the format that KVM would expect. We have to URL encode that and then pass that in to the parameter on the create virtual machine. For this to work, we would have to have huge pages and memory backing whitelisted and allowed in the global configuration. That's a security thing. Obviously, we don't want people to be able to pass any, or users to be able to pass any hypervisor parameters. Another example there, EHCI controller, etc. And then they're the global settings. So do we allow this at all? Yes, no. And then basically the whitelist for the three separate hypervisors. Nearly there. I think this is just about the last thing we've got to do. System VM diagnostics. This is a massive time saver. So again, system VMs, including virtual routers and secondary storage VMs and console proxy. If you have a problem with one of them, we all know that the traditional troubleshooting technique is SSH to that virtual router, start nosing around, try and look in different files, different bits of configuration, etc., etc. So this is just a lovely piece of automation from a management perspective. So I go to the system VM. I think in this case this is a virtual router. We've got this button here, which is download logs and diagnostics. You just press it, you click a link, and you then get in the browser a tab or a zip file, I think it is, open it up, and that has in it all of the things that at the global settings level we define that we think you need for troubleshooting. There's the default list, but I haven't got it. Yeah, diagnostics, data, global setting. You can change that list, right? You can get whatever files you want from that virtual router. So it's just a very good time saver in terms of needing to do any troubleshooting around IP tables, HA proxy, or anything like that. That wasn't the last one. We've got a couple more. VM placement. So CloudStack's got some very clever allocation algorithms. I'm sure you all know that, in terms of choosing what host to put a VM on. And if you think from a user perspective, normally to deploy a VM, you specify the zone, CloudStack makes all the other choices for you, okay? But from an admin perspective, every now and then we want to create a VM on a specific host to test something because there's problems with another host on it, and we want to see if that one behaves the same way. We just want to put a VM on the host we specified. So what you can now do, either on the API or on the UI, is choose zone, and then the pod within that zone, and the cluster within that pod, and then the specific host down to the cluster. And if you leave, say for example, I leave host blank, it will put it in that cluster, but then CloudStack will use its algorithms to put it on the host it wants to put it on. So you've got complete flexibility. That's a cloud admin only feature. A user would never see that. I think this is the last one. No, two more. Direct download for system VM templates. So direct download is the ability to bypass secondary storage when you're downloading templates. That is configured when you register the template. That's actually been there for a couple of years. I don't know. Andrea could probably tell you what version it came along in. What's changed here is you can now do that for system VM templates as well. So that's been brought up to the same level. I think this is the last one. Finally, we've got UEFI support. There's a screenshot there. Obviously, you would see that in the UI as well. Sorry, on the API as well. So I can, as well as BIOS, we also support UEFI, and then either normal or secure boot. Okay, that is everything. Just before we take questions, we're getting very close to time. Those of you who aren't already, I encourage you, please come along to the CloudStack website, have a look, get involved, get 4.14 downloaded, report any problems to the community, share your ideas, particularly around Primate, the new user interface, which is a tech preview. I will share these slides and video and everything afterwards, but a couple of places to go and look for more information. The release notes, that's the primary source. Also on shapeblue.com, the guys have been blogging about some of these features, specifically around feature first look. And a lot of those articles have got more detail than we've done today. So a lot of the things I've talked about today, you can go and find on our website. Okay, with 2 minutes to 4, we'll go through the questions we've got, because there aren't a massive number of questions. So realistically, I think we're probably going to get finished about 10 past the hour if we do all of these. Adam has asked, back up Seth, question mark, with a smiley face. I know what you're getting at, Adam, is, you know, does the backup and recovery framework support Ceph? The short answer is yes and no. It's a framework. If there is a backup technology that will back up Ceph, you can easily write the provider that connects it to CloudStack. So the framework is there for that, but it doesn't support it out of the box. You need a provider. The only thing it supports at the moment is Veeam and a dummy provider. But writing those providers isn't that difficult. I hope that answers your question. Andrea, do you want to take the next one here?
Sure, yes. The next, hope you can hear me actually, Josh, right? The next question is the backup stored in the synchronous mode? In short, when you do the backup, you send an API call to the Veeam if it's an ad hoc backup, or if it's a scheduled backup, then it will happen automatically by CloudStack. Effectively, this is, you can say, asynchronous in some sense, because the Veeam will simply get instructions to do its work. And we simply do that, and then we query the Veeam for the completion of the job. I believe by default on every 5 minutes or so this is configurable. And then you can see after the backup is done that it is actually done. It becomes available in CloudStack. You can restore from it, and so on.
Right.
Just you want to take over?
Yeah, I suppose the next one is a similar question from Nicholas. The answer is similar. It's a different question. Is the backup feature compatible with the XCP-ng in Zen server? Again, same answer. This is about finding a backup technology that can back up your hypervisors, and then just creating the connectivity between the two with the provider. So no, out of the box today, no, it doesn't, because Veeam, I think by definition, only backs up VMware. I think maybe VMware and Hyper-V. It's about what that provider supports. I'll take the next one, Mike. Which made me realize, Mike, we were meant to be doing a user group at your office today. So you get a webinar instead. Are there plans to move away from Core OS for the Kubernetes service? Yes, I was going to mention that. Sorry if I didn't. The underlying ISOs for the Kubernetes service are based on Core OS, which is already end of life. There are discussions afoot in the community. I think Flatcar or Alpine were the two favorites going on. So by the next version, it will be not Core OS. It will be one of the above. Do you want to do the next one, Andrew?
Sure. So the next one was from Ni about, well, let me read it actually. With the idea of keeping the code tight, should things like VM ingestion not be implemented as something like a plugin or even a separate script, as it is something that people will not use on a daily level effectively? So not really, because there is a lot of moving pieces. We need to recognize and read all the properties of the VM, like different network controllers, disk controllers, network controllers, disk locations, all things like that. And then we need to have a proper interface to write all this data back into the database. It's the opposite of when you actually deploy a VM via CloudStack. So actually doing this as a completely standalone thing would be very hard to do because we are using a lot of a lot of code, if you like, existing code, and a lot of new code has been developed to actually be able to support this feature. So yeah, the answer would be no, I guess.
Do you want to answer Zuma's,
sure.
Usmar's question about containers?
Yes. So there's a couple of questions there. So the first, I apologize, I hope I read the name correctly, as Asma or Isma. What is the limit of containers we can have in a cluster, minimum or maximum containers? Short answer is there is no limit from CloudStack perspective. So whatever is the default limits there in Kubernetes, that's effectively what what you can do, and obviously the underlying hardware and so on. Next one from the same gentleman is, does it support both scaling in and out functionality, and what is the default scaling algorithm it follows? So to put it short, we don't support auto scaling yet. You can scale up and scale down the number of worker nodes via CloudStack. That's something you do manually via API or GUI, but there is no auto scaling. Next one from the same gentleman is, how does it perform health checks of the containers for scaling purposes? Again, there is no auto scaling. That's the short answer. But in general, we do obviously communicate with Kubernetes via Kube admin, I believe, to do the necessary provisioning and querying of different things and so on.
And Andrew, if I could just jump in, it's worth mentioning there because it's very relevant. I believe auto scaling of the Kubernetes service is in the next release, which is going to be based on Kubernetes scaling algorithms, and then talking to CloudStack to actually create the new worker nodes. I believe that's the case. I can probably send you some more information on that if you need. Sorry, Andrew.
Okay, yeah, thanks, Charles. Next one from Vivek. Will the Kubernetes cluster work effectively under VPC router? In short, no. When you create a Kubernetes cluster, you can either auto create network out of by using actually the previously defined via global setting defined network offering, and it could be a shared or an isolated network, not a VPC isolated network. So the short answer would be no, but regular isolated networks, which still means a virtual router, but just a single network behind it, is what you will be able to use. Then there is a VM ingestion question from Maurice. Can we import VM into the project? Short answer, yes. You can effectively, when you import a VM, you assign this VM to another user or to a project. So that hopefully answers that question. Again, from Uzma, the question was, can we define the time interval for pulling the virtual router for detailed health checks? Yes, by all means, that's configurable via global settings. From the same gentleman, question again on the same topic, can we integrate the virtual router health checks with third-party monitoring portals? As Jars already explained, you can pull, you can talk via API to the CloudStack to, well, pull the latest health checks of specific routers. So the question would be yes, or you can query the underlying table, maybe with a read-only SQL queries, or you can monitor your management logs or API for alerts. So yes, in short, yes, there are a couple of ways to do that depending on what you want to achieve. Amidst the webinar is going to be published. Yes, it will be present as a recording, I believe, on our video channel. From Marcelo, is there a roadmap to improving Hyper-V support? Giles, do you want to take this one?
Yeah, sure. Yes, there is, Marcelo. I know of a user organization who is driving some improvements. In fact, I'll change that wording. A complete refactor of the Hyper-V support in CloudStack, which is, to be frank and be open, has never been satisfactory. So yes, that will be appearing at some point. Should I continue for a few, Andrew? I think I know. Sure. Can we also get to check the logs on the UI, Uzma asked. Sorry, I don't quite get that question.
I thought this was maybe with the diagnostics, around the diagnostics, downloading the thing. So that you actually download the whole zip file with all the logs and everything. So you don't display.
Okay. Download diagnostics. Yes, it's expected to be. Yes, you click the button in the UI and boom, up pops a zip file with all of the logs in it. Another question: are VM ingestion and backup only supported in VMware? Two different answers. So yes, the VM ingestion that we have in 4.14 is designed only for vSphere, sorry, vCenter at the moment. That is the use case that's driving it. Although there is a lot of discussions around also being able to import from other hypervisors and things. So sort of watch this space. Backup is designed to allow anything to be backed up. It's just the provider that's been written for Veeam only is. I think Veeam are Hyper-V and VMware, but they don't support the others. So the process with backup, if you want to offer backups, is go and choose the backup technology you want, whether it's hypervisor level or agent based or what have you. As long as it's got an API, a provider can then be used to connect it to the backup framework. I don't know the answer to Thomas's question. Can you answer that one, Andrea?
Yeah, the question is, many backup solutions are based on UID in Zen server. This is again, and so on. Did anybody consider this? So the thing is that, as Giles already mentioned, for the moment, we only have Veeam provider implemented. So in general, at the moment, there is only VMware support to backup VMware-based CloudStack instances via Veeam. You could obviously develop integration between some other software that supports backing up Zen Server or KVM or something else or Ceph, but that kind of support needs to be there. The framework is there, the basics is there, so you can easily develop the integration between CloudStack and some other backup provider, which is only done, as I mentioned and just explained, for the Veeam. Another similar question: Veeam supports only VMware, right? For the moment in CloudStack, yes. But again, it's extensible. From Vivek, if any VM can share disk running in clustering VMware in case of Aurora, will also import the VM? Good question, Vivek. I would say the answer would be, I actually don't know the answer, to be honest. I believe the answer would be no, because we in CloudStack in general don't support sharing a disk between instances. So I would be extra careful trying to do such a thing, but it's a good question, something we might handle in future. Are we using Cube admin or KS hardware for multi-master setup? We in general use Cube admin or whatever you would like to pronounce that. I can't specifically answer this question, but yes, we use Cube ADM for general communication from CloudStack to the Kubernetes cluster. Another one from Anthony: is it possible to back up a VM in one zone and then VM ingest it into another zone? That would be an interesting exercise, but I'm not sure that's possible at the moment. No. Great stuff, by the way. Thank you. That's